We've come to the end of another year of the energy seminar. And every year at the end, we try to do something really fun. I don't know if those of you remember when we had the big electric car demonstration project over in the Y2E2 garage. But anyway, that was fun. And sometimes we show films. And this year, the funnest thing that I could think about was to get to learn more about the solar decathlon project. And for those of you who walk around campus a lot, you might have seen a building going up, I think it's right across from Mitchell building, yeah, right across from where Terman used to be. And anyway, that's the project. And so today we're going to learn about that. And as you can see, it's called Start.Home. And the plan will be is first we'll have a short lecture, then there'll be time for all kinds of technical questions, and then we'll all get up and we'll go over to the project, and we'll get to go inside and so forth. So anyway, I'm really excited about it because I've been watching you build it, and I think it's just fantastic. So just a little bit of logistical details. You will need to sign a release in order to go into the home, and we do have release forms in the back. So after we finish the discussion, just as you're on your way out, please pick one up. For those of you who forget, we do have them over at the house as well, but it will make shorter lines if we pick some of them up here. Yeah, so that's that. And then just in addition to getting a tour of the house, we'll have a reception over there with food and so forth. So you're all welcome to join us for that. I just want to say one more thing. For those of you who got to participate in the Rising Power mini-series about China and China's energy situation, I personally thought it was fantastic. And Jeff Ball really deserves the credit for pulling together a really interesting series and conceiving of that and delivering all those fantastic speakers. Who, if you read the newspapers, a lot of them we hear about. The solar industry over there is just going through really huge convulsions, and those are really the frontline people who we got to hear from. So anyway, thanks to Jeff, who's not here, but those of you who talked to him, please pass along my thanks. Okay, so now we'll get to the main plan for the day. So we have 4 different speakers who are going to talk to us, and they are the leadership team of this project. And the first of them, and I will say, like reading their bios, it's absolutely astonishing. I think they have like 20 degrees between them, and they're only like 12. But anyway, so to start off with, Derek Ouyang is a senior who received dual BS degrees in civil engineering and architectural design. He's from Arcadia, California, and he's the project manager for Stanford's first solar decathlon team. So this is the first time we've done this. After the competition, he's going to be pursuing an MS degree in structural engineering here at Stanford. So we'll get to keep him for a little longer. Rob Best is a PhD student in civil and environmental engineering. He has a BS in engineering from Harvey Mudd College and an MS in civil and environmental engineering from Stanford. He's the design manager for the Stanford Solar Decathlon team. Previously, he's worked in energy and environmental consulting and research sustainable cities and building policies. Next on the list, we have Felipe Pinchera, who's an advocate for interdisciplinary work and radical collaboration. He has a double BS, and he is currently pursuing a double MS in mechanical and civil engineering. He's the mechanical team leader and one of the original members of the Stanford Solar Decathlon team. Previous experience includes projects in power systems and energy efficiency of buildings, and his new passion is design thinking. He's originally from Constitucion, Chile, and loves all kinds of fun things that we all love too. And finally, Colin Lee is an MS student in electrical engineering. He received his BS from Santa Clara University with a double major in electrical engineering and computer science and engineering, and he's the control team leader. So please join me in welcoming this fantastic team.
Thanks so much, Sally. So today we're really excited to give you guys a sneak peek at hopefully what's one of the most exciting energy projects on campus today. This will be the basic outline. But first, I just wanted to give you a sense of what the competition is. It's called the Solar Decathlon. It's an international competition sponsored by the U.S. Department of Energy. And they challenge 20 collegiate teams every 2 years to design and build solar-powered homes that are affordable, attractive, and easy to live in. And these homes are built all around the world. But then for 2 weeks this October in Irvine, California, they'll all come together. They'll be shipped to create a sort of solar village. And there'll be public tours and also contests to determine sort of which is the best house. And this is where it will go in Irvine, California. This is sort of, we took this as a student initiative, really, to make it happen at Stanford. It's never really taken place on this university campus before. And we saw it as a huge opportunity to take the kinds of things we're learning in the classroom environment and textbooks and research and actually apply it to a real, highly complex, interdisciplinary building project. And it's sort of like bridging the gap between learning how energy efficient buildings work and actually proving they work, and in many cases, hopefully making them better. The Decathlon judges all 20 teams on 10 contests, ranging from architecture and market appeal to engineering and temperature comfort. And so they really challenged all 20 teams to be excellent in all areas of building. And that's taken for us a really interdisciplinary team of over 50 students from freshman level to PhD to work on this for almost a year at this point. And we've gone through many designs to come to a final project proposal that we think will be a winning one. But actually, the point for us isn't to win. We actually hope that through this opportunity that's been given to us, to actually come up with a much larger idea, to come up with things that can actually inspire change in industry beyond the decathlon. And so today, in the very short time we have 3 team leads here that will share the visions we have in construction, in building systems and energy and control systems, ways we think will hopefully change how you think about energy efficient buildings. And then we'll have just a little bit of time for questions, probably on the way to the actual project. And you guys will get a chance to see it in mid-construction. So without further ado, take it away, Rob.
Thank you, Derek. So I want to start off by talking a little bit about buildings and a little bit about homes, especially here in the United States. Some of you may not know, buildings actually consume about 40% of our primary energy here in the US and contribute to about 35 to 40% of our carbon emissions as well. That actually incorporates 75% of our electricity use. So the fact that we talk about buildings and we talk about finding ways of making buildings more energy efficient is actually very relevant to a huge swath of our environmental footprint. Within buildings, for those who aren't aware of their construction, heating, cooling, and lighting provide the greatest uses of energy and therefore the greatest places where energy tends to be wasted. What's interesting about buildings as opposed to some other energy systems is that if you look at a life cycle perspective, over 80 to 90% of the impact comes from the use, but because of all of what's embedded in construction, the efficiency of those systems, the way that they're used, that all happens in decisions that are made very early on in the building's life cycle. Now, often we can retrofit and we can change things later on, but it becomes far less efficient from a cost perspective, as well as from just an energy perspective to try and add new systems in. So with all these things in mind, our big question came to how can we build a smarter building, something that's adaptable, something that's a comfortable residential space, and do it in a way that we reduce both upfront and use phase energy emissions. Now, keeping in mind that use phase is more important, we still want to focus on the upfront because that's still something we should be caring about. What we came up with was the concept of a core module. And Felipe and Colin are both going to talk about this a little bit later. We looked at prefabricated construction and we said, well, there's a problem here. And that problem is that no matter how good a prefabricated home is, it's hard to penetrate the market. They're cookie cutter. People don't really like them. It gives you less opportunity to actually make the house what you want it to be. So we said, let's take the most complex parts of the house, put it in a single module, pre-manufacture it, pre-package it, and then you can take this, you can ship it anywhere in the country. It's designed to fit on a transportation, on a truck and meet all transportation requirements. Put it into any house and design what you want around it. This becomes the engine of your house. This becomes something that makes your home ready to be energy efficient and networks you with your energy use. Then we took the concept here in Palo Alto. We said, let's look at some of the passive systems. Felipe is going to talk a bit more about that later. And we built a house around it. And Derek's already showed you what our concept is. Because the competition requires that we transport the home, ours has to be decomposable into elements that we can also fit on the back of a truck. So we fit it here into 4 main modules plus a decking structure. And this pushed us to think a little bit further. We said, well, what happens in the house when you build it, when you use it? This here is a 1-bedroom house with an office. What happens when your family grows? Do you really need to buy a new house? So he said, well, maybe this core is the start of a central space and is the start of multiple house iterations. What if you could pre-manufacture all of these components, but not as far as single units, not as single floor plans? What if it was configurable? And this is taking this a step further. So even if you could build any house you want around the core, what if you try and embed some more efficient systems from the upfront process? This is not a far-fetched idea. Homes are already pre-manufactured. This is a factory that we got to tour in Sacramento, California, and just one of many examples across the country and here in California. But we took the idea of our house and said, this is what we have for the competition. We have a public space and a private space. It's for a single family. A child comes along and perhaps you want to add a second bedroom. We actually get the opportunity to demonstrate this because as the home comes back to Jasper Ridge Biological Preserve after the competition, the resident ranger and his family need a second bedroom. So we'll be adding this module then. Perhaps your family grows, you need a third, and then even a 4th module, a 4th bedroom to fit your house. So here, rather than building another house and embedding all of those emissions, all of that life cycle impact into it, we've taken the same structure and we've adapted it throughout the use phase of the home. We've also done this by making our construction easier. We're using a technology called structurally insulated panels, which are pre-made in a factory. They come together very quickly on site. Here they are being delivered to our actual construction site. This actually reduces the time and time of construction, and provides a very tight energy efficient envelope that forms the basis of any energy efficient house. Remember that the most efficient energy to save is the energy you never use. So by insulating and providing an airtight house, we get the opportunity to downsize our systems, which Felipe will talk about what we've actually built, and make the house more energy efficient. Construction becomes fairly easy, so it saves on cost and schedule. And if you pre-manufacture other wall assemblies as well, it becomes very easy to put the home together. So we framed the whole house in just about a week, which is a very short time for a lot of residential homes of this size. Once we have the house framed, though, it's all about then what goes inside and how you connect to that core module. And so Felipe is going to talk about the mechanical systems and some of the energy efficiency that we've built in there.
Okay, so I will tell you about the passive strategies that we have used in this house. We wanted to reduce the mechanical systems as much as possible, always taking into consideration the competition. So first thing we did, this is a psychrometric chart, so we look at different strategies to achieve this thermal comfort throughout the entire year. And what we realized is that about 8% of those total annual hours can be achieved actually through natural ventilation. And the climate here, once we bring it back to this area, the climate here is very nice. So we can actually use natural ventilation a large portion of the year. So with that, we also didn't want to forget about the competition. So we started looking at the wind patterns in Irvine, California. So this is the wind rows during the time of competition in Irvine, California. And we realized that most of the winds actually are coming from the southwest corner. So after looking at that, we start designing the house like towards trying to like achieve maximum wind from the southwest. It's not working now. Oh, there you go. Okay, so this is how our natural ventilation works. So as you can see, your right side, that's the south part, and then the left side is the north part. So from the south part, we actually introduce air from the like around feet high, and then we have a north story windows in order to take advantage of cross ventilation and also the stack effect. So when the windows are closed, we're going to have a stack effect, and the hot air is going to rise. But when the windows are open and it's nice outside, we're going to have cross ventilation, and we're going to move or push all that hot air out of the house as it crosses the living module. Now these two windows work in sync, and through our control system that they're calling, might dig a little bit more into the detail in there. But by analyzing the weather outside and then also the interior conditions, we want to determine when is the proper time to open these windows, and also when is the proper time to have them closed. So we will do that whenever the time is appropriate. But then we didn't want to stop there. We actually, DuPont actually contacted us with a new product, which is phase change material, which pretty much replaces thermal mass as concrete. Since we actually have to move the house to Irvine, California, and we had to like disassemble and assemble so many times that concrete wasn't really a feasible option for us. So this just like came great for us. And what we're doing is we're using the PCM in the ceiling. And what the PCM does is just works like a thermal mass. It absorbs heat during the day, and then it releases heat during night. So what we can do is night flush. So when it's cold outside at night, we will just like recharge in a way the PCM, and then it will be ready for the next day to start absorbing heat again.
So does it actually change phases?
Yes. Yes. So as it absorbs heat, it gets to like a liquid state, and then as it releases heat, then it gets to a solid state. And what's great is that that material actually it's perfect for the range of thermal conditions that the Department of Energy sets for the competition. Now that product, it's not available here in the United States right now, and they've been using it in commercial buildings in Europe. So they want to use our house as a case study for this product and try to like come into the United States for the market. So then the HVAC system.
How does its weight compare to concrete?
Yeah. So for 8 centimeters of concrete, you can achieve the same thermal absorption with 10 millimeters of a thin panel. Yeah, so they come great, and it's just like 1 meter by 1 meter panel flat that you can just put in between your finish and your gypsum board. Okay, so basically we have the core, right? We want to concentrate most of the mechanical and electrical systems in this core. But because of the competition, the main thing that is not inside the core and actually goes along the message that we want to have with this house of expanding it is actually the HVAC system in terms of heating and cooling. So what we're using is we divided the house in 3 thermal zones. So as you can see, you have 3 indoor units, and then they are all served by 1 outdoor unit. This provides control and also adequate temperature in each one of the rooms in the house, which was a main concern for us since in the competition we have a thermal comfort contest that we always have to stay within 71 and 76 degrees Celsius and below 60% humidity. So we needed something that was responsive because people who's going to be touring the house, it's going to be really hot outside, and then they were going to give us 30 minutes to bring the interior conditions to whatever they wanted, between 71 and 76. And then the other one is that you can start adding other equipment as your houses start expanding. But besides that, everything else is in the core. So you can see there an HRV, which is a heat and recovery ventilator. That's actually situated on the ceiling on top of the ceiling of the core. And that supplies air to all 3 living areas in the house. And then we have the plumbing as well. Everything is in the core. I don't have time to show the plumbing. So that's a picture of the outdoor unit. So that actually works with all 3 interior units. And then that's pretty much how it looks, the interior unit. Now Colin will talk to you about systems, control system.
Thank you. So when we started looking at how we were going to design this control system for Star Home, we really tried to approach it with the same kind of design rationales that we had with the core. I mean, we tried to make it factory built, plug and play, modular, and flexible for customization. But since this is an energy seminar, I figured I should probably focus on how control systems relate to energy efficient homes and how and the concept of energy conservation in homes. Oh, sure. So recently, when you look at kind of the control systems we have in the market today, they focus mainly on optimizing efficiency. And when we look at most of these products, they're optimizing the efficiency of subsystems like HVAC systems. So we looked at this and we thought, this is a very, very good idea. But we took it kind of a step further. We decided that not just integrating, we didn't have to just use the active systems, like Felipe said, we could use all the passive systems as well. We look at HVAC control as a full continuum from passive all the way to active systems, and we use that as a single control algorithm. The way we think about this is the more components and the more sensor data and the more things you can add into your control system, the more effective and efficient it can be. But the problem with this is that control systems don't like things that are random or unpredictable, and it just doesn't do well when you just have events that you don't anticipate. I like to call these events users. So we do all this work in our control systems, we try to optimize them, but then the user comes along and does something suboptimal. I don't know, like turn on the lights or plug in appliances. I mean, these are things we as control systems engineers, we don't want the user to do that. And the way we approach it, or the way a lot of modern home control systems approach this, is they try to design out the user. They try to optimize out the user. They try to ignore the user. But we really thought this is not the way we should do it. We really took this and we turned it on its head and we took the opposite approach. We believe that the user is an integral part of any definition of comprehensive sustainability. It's not just about smarter homes, it's about smarter people. And we believe that given the choice, people would choose to be more energy efficient. And that's why our main goal is to empower people to make these energy efficient decisions. Now, the first step we have to do in order to make people, or empower people to be more energy efficient, is to give them data, to inform the user. And well, the problem is, in terms of energy efficiency, what energy usage today is kind of like walking into a grocery store where there are no price tags. You walk out of the grocery store without paying, and then they send you a bill at the end of the month. So trying to affect user behavior and trying to help the user make more energy efficient decisions in this paradigm is really not helpful. So we really have to rethink how we present data to the users. So in our house, we monitor every logical use of power, whether that be outlets, lights, or mechanical systems, and we present them to users in real time. This is our web app we have here. And the idea here is that we're really trying to inform the user to make the correct decisions or make energy efficient decisions. But simply informing the user, simply just giving this user the data isn't enough. I mean, this is kind of like if I just sat here and nagged you that you're using too much energy every day and you have no means of correcting this. So not only do we need to provide the user with the data, we need to provide the user with the ability to make changes, both easily and effectively. So in this concept here, not only do we have the data visualization here, the control of the whole house is also from this interface. Every element you see there, every element that you can, all the data that you see there, you can touch and you control those elements that are actually using power. But in addition to this interface, we thought we wanted something more simple, something that you could place around the house. And for that, we thought of, well, light switches. We have light switches all around the house. These are places where you can control elements. But they don't give you any feedback. They don't tell you how much energy you're using. So our idea is, well, what if your light switch did tell you how much energy you're using? We call this the room switch. It has, basically, it's just an ambient representation of how much energy you're using in the room, basically with just color. You can, at a simple glance, you can look at and know how much energy you're using. And the idea here is you're putting the data right next to your action. You can see how your actions contribute to your energy usage. So imagine you're leaving your room or you're leaving your house, and you walk past your room switch and you see that it's drawing energy. So maybe you decide that, oh, you probably left something on, maybe you want to turn it off. The power of an integrated control system is that with a single tap, you can turn off the entire room. That's why we call it a room switch. So really, what we're trying to optimize, what we're trying to influence, is we're trying to minimize the resistance users have to being able to take information and convert that to action. The flow from information to intention to action is effortless. When a user is informed and executing his or her intent, and when that intent is effortless, you can truly start to affect energy usage in a home. Whole house control and automated control and data visualization individually may not be able to help this problem. But when we start to look at them together and we start to think about this differently, when we start to think about how we can use these to influence, how we can use these to influence the user and how we can allow the user to make better choices, we can really achieve this idea of smarter people. So ultimately, we don't think of smart home as a smart home. We envision it as technology that enables smarter people. We aim to provide you with this kind of enabling technology. We aim to provide sustainability at the push of a button.
So this is a quote that I actually used at a talk at TEDx Stanford about the same project. And I think it's a really good sort of recap on the approach we take to sustainable buildings, and hopefully something you'll take away from this as well. It's really been a part of everything we do in this project. And first and foremost, it's an amazing educational experience for us. We've basically been out there designing this from scratch, building it from scratch, and also raising all the money we need from scratch, which has been really exciting. This is a time lapse of construction of a spring break where a lot of students actually stayed and did most of the major structure in that period of time. The house will go down to Irvine, like we said, but also we wanted to make sure that it extended much beyond the competition. So we worked with the university and many schools and departments to try to find a home for the home. And luckily, we found a permanent place right here on campus. It'll go back to Jasper Ridge, and it's just on the other side of the 280. A beautiful nature preserve where actually the resident ranger and his family will be able to live there. And this is the perfect thing for us because we can actually also test the systems and make sure that they're reliable over the entire life cycle of the home. So these awesome people will be our guinea pigs. We've also been reaching out as much as possible to K through 12, to the local community, because hopefully when these guys grow up, they will be demanding these kinds of homes and this kind of interaction with maybe something like the core. I want to take a little bit of time to thank our university and industry partners that have been helping us through cash, through in-kind products that go into the house, and also through mentorship. So there's no way we would have been able to do this without their help. And I encourage everybody here to continue following this project all the way to October. You can see our updates on our website, on our social media channels, and just learn more about our project. But I think now you guys are going to be able to benefit from a sneak peek at actually the house itself. Since we're running a little bit low on time, I think what we'll do is we should just all, if you want to go see the house, just come with us. It'll be a 5-minute walk. And during that time, there's actually quite a few members of the team in the audience right now. Actually, if you raise your hands if you're part of the team, you can basically ask questions to these people as we go down, and they're all involved in many aspects of the team. Once we get down there, I think there's a sort of reception. There'll be I think food and beverages, and also a physical model of the house, but then we'll start to bring people in groups of 10 or 15. There'll be release forms in the back and also more at the site. So you just have to sign those. We'll have PPE, hard hats, gloves. It is important that we will require that you're wearing closed-toed shoes and lawn pants and sleeves. So unfortunately, if you don't have those, you can't go in today. But otherwise, you'll be free to go in, and yeah, we'll just have some fun out there. All right, thank you so much.
That's for our